In this video, we are going to be talking about how to calculate wave speed. Our equation is below, and we'll just go over the variables really quick. So this is V equals lambda times frequency, where V stands for wave speed, just like V stands for velocity, velocity wave speed, and this is going to be measured in meters per second. This is our Greek letter lambda, okay? Lambda, and then this stands for wavelength. If you don't remember that, that's fine. And wavelength is measured in meters, so that's your lowercase m. And lastly, we have this italicized F. This stands for frequency. This is going to be measured in 1/, seconds, or something that they call hertz. So 1 hertz is the same thing as 1/, seconds, either one. So when you multiply these two together, when you multiply meters times 1/, seconds, that's how you get meters per second in terms of the wave speed. So let's jump right into our first problem here. So a wave has a frequency of 35 hertz and a wavelength of 2.8 meters. What is the speed of this wave? So we line up our variables. It's asking for wave speed, which is V. Our lambda, remember that's measured in meters, so this is going to be 2.8 meters. And hertz is frequency, so 35 hertz. All of our units are correct here, so we just need to multiply these two numbers together. So 2.8 times 35 hertz, I should put 2.8 meters. This gives us a value of 98, and again with our units, a hertz, remember that's 1/, second, so this is meters times 1/, seconds, which gives you meters per second. That's also the correct unit for velocity. The lowest pitch that an average human can hear has a frequency of 31.5 hertz. If sound with this frequency travels at 457 meters per second, what is the wavelength? So line up our units. It's asking for the wavelength in this one. So last one we solved for wave speed. Here we're solving for wavelength. Our frequency is 31.5 hertz, and the wave speed is 457 meters per second. So in this one, we're going to have to rearrange our formula to solve for lambda, or wavelength. So in order to do that, we need to get lambda on a side by itself. So we're going to divide both sides by frequency. Those are going to cancel out, and it's going to leave us with lambda equals V over frequency. Our units are correct, so we can simply just plug in 457 meters per second divided by 31.5 hertz. This is going to give us a value of 14.5. Now you can just simply remember that wavelength is expressed in terms of meters, or you can cancel out these units like we've previously been doing. For our last question, a wave traveling at 410 meters per second has a wavelength of 5.8 meters. What is the frequency of that wave? So before, in the previous questions, we were asked for wave speed, wavelength. Now we're solving for frequency, so frequency gets the question mark. We have 410 meters per second as a wave speed and 5.8 meters. So again, what we need to do here is rearrange the equation to where frequency is on a side by itself. So this time we are going to divide both sides by wavelength. That's going to cancel out on the right. So it leaves us with frequency equals wave speed over wavelength. Our units are correct. So 410 meters per second divided by 4.8 meters. Here our meters cancels out, and it leaves us with a frequency of 70.7. And this seconds, remember, it's divided by, so it's actually down here on the bottom. So this is 1/, seconds, which equals the same thing as 70.7 hertz. So that's going to be our answer here. Again, if you have any questions or need any help, please send me a message and let me know.